Today, I want to explain why this is the rotation matrix. So what we mean by rotation is the following. We are going to rotate like a point counterclockwise by angle theta. So I will just say counterclockwise by the angle theta like this. So here we go. The idea is that if you observe the following, let's say we have a point on the plane right here. Let's call this classic, x, y. And I'm going to rotate it clockwise, which is like this, by the angle theta. So I'm going to get to this new point. I will call this x new, y new. Here is the key. When we do this rotation, one thing is that we are going to maintain the distance from the origin. So if you call this distance r, you will have r right here as well. So that's a very nice rotation. So how are we going to figure out the coordinate for this new point? Well, check this out. Firstly, we have x, y, r. This right here is an angle as well. I don't know what it is. I'm going to call it alpha. So based on this, you can kind of see that x is going to be what? Cosine alpha equals, this is x, this is y. So adjacent over hypotenuse. So x is r cosine alpha, just like our usual conversion formula for the polar. In fact, it's just polar. I'm using alpha, that's all. And then sine of alpha is opposite over hypotenuse. So y equals r sine alpha. Now, once we get to this new point, what will happen? X new, it's going to be what? All we have to do is just go ahead and look at our original x. We have cosine alpha. The whole thing from here to here is alpha plus theta. X new will be r times cosine of alpha plus theta. And then likewise, y new is going to be r sine, and we will have alpha plus theta. So far so good. Now the rest is just work them out. How though? Angle sum formula for cosine, angle sum formula for sine. So keep the r on the outside. This is going to be cosine of the first times cosine of the second minus sine of the first times sine of the second. If you distribute r, you see that this times this, r cosine alpha is what? That is the x. And then we still have this part we don't have to distribute, is the r cosine this part. And then distribute this to here. We get minus, if you pair out r with sine alpha, you get y. And then you have sine theta here. So r paired with this, you get this. R paired with that, you get that. Now do the same thing. Here we get r, and then the angle sum for sine, we can write sine of first times cosine of the second plus sine of the second times cosine of the first. Same thing. Distribute r pair up with sine alpha. That will give us the y times cosine theta plus r times this part pair up with the cosine alpha. Together that will give us x, and then times sine theta. So as you can see, we have our new components for the x new and also y new. Now next, this is what we are going to do. We are going to put this and that into a matrix form or a factored form, depends on how you want to look at it. So here is our next new, and then here is the y new. For the x new, I have x cosine theta minus y sine theta. And then for y new, we have this. But notice that right here we have the x going first already. So this is what we'll do. I'm actually going to put this down first. X sine theta, and of course we just have to add that with y cosine theta. Why do we do that? Because check this out. We want to have the x and x right here and then the y and y right here when they match. Because this way we can separate them into a multiplication of two matrices. Check this out. I'm going to put down these right here in a matrix, which is going to be the rotation matrix, cosine theta, and then negative sine theta, and then sine theta, and then the last part right here is cosine theta. And by the way, if you have done some calculus already, and by the way, many of you guys might notice this already. If you look at this as the x component and also the y component, cosine and sine, very reasonable. How do I remember this? Take the derivative cosine, you get negative sine. Take the derivative sine, you get positive sine. Very nice, huh? Anyways, where's the x and y? Well, I just had to do a matrix multiplication with x and y. Because remember, when we do matrix multiplication, we do the dot product of the row and the column. Meaning, we take this times that plus this times that. And that will give us exactly this. We have two rows, yeah? And then right here, the second row is this times this, which is that, plus this times that, which is that. Perfect. And ladies and gentlemen, this is the rotation matrix. That's it.